Hello, dear friends. In our last session, we have seen various types of a nuclear reaction. Depending on what we are getting in the product side, there are various nuclear reactions has been classified. Here, in any nuclear reaction like this, a lighter particle, projectile particle, it hits the target nucleus X. Some nuclear reaction will take place in between these two reactants, and as a result we will get a heavier nucleus, what we called it as the product nucleus, along with a lighter product particle, right? Now what is going to be takes place here, that means what is the thing that convert reactants into a product, we call it as the nuclear reaction mechanism. How a nuclear reaction will takes place, right? This we have to study under the head of nuclear reaction mechanism. Now there are mainly two types of a nuclear reaction mechanism. There are mainly two types, that is the direct nuclear reaction and compound nuclear reaction. Direct nuclear reaction and compound nuclear reaction. Now, whenever we say that a nuclear reaction is going on, some reaction is taking place here, means obviously there is some exchange of energy. The energy will be exchanged between these two reactants. As a result, we will get the products. Now, how this energy will be exchanged, that classify the nuclear reaction into a direct nuclear reaction and a compound nuclear reaction. Now, in case of direct nuclear reaction, what is going on? Suppose this is your target nucleus. Obviously, it will have number of nucleons inside it. That means protons and neutrons collectively, what we called it as nucleons. So, inside the target nucleus, there are number of nucleons. Now some lighter particle X will bombard on this target nucleus. In case of direct nuclear reaction, the energy associated with this incoming particle will be absorbed by a single nucleon, as a result of which the nucleon will either skip that nucleus or it will be absorbed by that nucleus. This incoming nucleon will be absorbed by this nucleus. So, this reaction in which the energy exchange will take place or the exchange of a single nucleon will take place, we called it as the direct nuclear reaction. Here, nothing will happen to the rest of the nucleons of the target nucleus, but only one nucleon of the target nucleus will interact with the incoming particle. The time duration of this direct nuclear reaction is equal to the time that is taken by this incoming particle X to cross this nucleus, right? Whatever time will require by this lighter particle X to cross this nucleus and come on another side, that much of time is required by the direct nuclear reaction. It is of the order of 10 to the power minus 22 second, right? So this direct nuclear reaction, we can say it is a single step immediate reaction. Why immediate? Because this incoming nucleon is not at all residing here. It is taking the time, only that much of time that is required by this nucleon to cross this nucleus immediately. So, this direct nuclear reaction is a single step immediate reaction in which the incident particle interact with only one nucleon of the target nucleus. The incident particle, it interacts with only one nucleon of this target nucleus. We call this reaction as the direct nuclear reaction. On the other side, what may happen? The energy that has been absorbed by this target nucleus from this incident particle, this energy, instead of interacting with the single nucleon, it may interact with all nucleons present in that nucleus. It may happen, and these type of reactions, we called it as the compound nuclear reactions. Compound nuclear reactions. So what will happen in the compound nuclear reactions? In compound nuclear reaction, the incoming particle x, small x, it will give its energy to one nucleon. It will goes to the excited state, and while coming down, it will excite the neighboring nucleon. This will disturb it another neighboring nucleon, and in this way the energy of whole system will be changed just because of the entry of this lighter particle x. So these type of nuclear reactions, in which the kinetic energy of incident particle is shared by all nucleons of the target nucleus. This type of reaction, we called it as the compound nuclear reactions. Compound nuclear reactions, right? And this compound nuclear reaction, unlike to the direct nuclear reaction, it is a two-step interaction. Two-step interaction. What are the two steps? In first step, the lighter particle X, it will be absorbed by the nucleus. It will be absorbed by the nucleus. The energy will be shared by all nucleons, right? The energy will be shared by all nucleons. And up to what time this energy will be shared? This energy will be shared among all nucleons unless and until this nucleus will achieve a statistical equilibrium. A statistical equilibrium. The energy will be shared by all nucleons inside the nucleus, so that a statistical equilibrium will be achieved. And after that equilibrium condition, the energy or you can say there is no transfer of energy that will be takes place among these nucleons, right? So in this way, after achieving a statistical equilibrium condition, we can say a compound nucleus has been formed. A compound nucleus has been formed. Now at this moment, this compound nucleus has been formed in such a way that it will totally forget that how it has been formed. Now it has no, you can say it has been totally forgot. It has forgot the formation, that is how it has been formed. It has its own state. This phenomena, it is well known as the Bohr's independence phenomena, right? Bohr's hypothesis of independence, because this compound nuclear reaction, this concept has been proposed by Niels Bohr, and he said that, let us say it as the independence hypothesis. Means once the compound nucleus has been formed, it totally forget the way of formation. And as it has forget the way of formation, obviously this compound nucleus has a lot of ways of disintegration also. There are many ways that by which this compound nucleus can disintegrate. So formation of compound nucleus is one step, and disintegration of compound nucleus is another step. Again, the disintegration process will be totally independent of the formation process, right? Disintegration process doesn't mind by what way this compound nucleus will form. It will have its own way of disintegration. There could be many ways of disintegration, right? And how this disintegration process will take place? We have said that this compound nucleus is in the statistical equilibrium position, right? So while disintegration, there are statistical fluctuations. You have studied the energy fluctuations in statistical mechanics. So that energy fluctuations could take place here, and we can say that the compound nucleus that has been formed in first step is now going to be disintegrate. So disintegration is the second step, right? Again, indirect, the very important thing here, indirect nuclear reaction, the interaction time is so short, or you can say the reaction will take place in such a short time. It takes place so immediately that within this small duration, the forward momentum of incident particle will not be lost, right? Forward momentum of this X remain the same even if it interacts with the nucleon inside the target nucleus. Forward momentum will remain same. Means whatever particles we will get in the product, they are mainly focused in the forward direction. Here the motion of this direction, or the direction of this motion, is in forward direction, right? But in case of the compound nuclear reaction, as we have said, that once the compound nucleus will be formed, it totally forget the way of its formation, and as a result, the form and in this way we can say the forward momentum of the particle will not be conserved, will not be same here, but the particles that has been formed in the product, they go in any direction, right? In any direction here, like this. So they will distribute isotropically in all direction, unlike to that of the direct nuclear reaction, in which the product particle is mainly focused in the forward direction. This is another thing that you have to remember about the compound nuclear reaction. Again, although it is a two-step interaction, the time duration of compound nuclear reaction is quite longer compared to the direct nuclear reaction. For direct nuclear reaction, the time duration is equal to the time taken by the nucleon to just cross over this nucleus, and is equals to 10 to the power minus 22 second. Whereas in compound nuclear reaction, this time is of the order of 10 to the power minus 19 second. In some book, they have given it as 10 to the power minus 16 second also. So although this time period 10 to the power minus 19 second, although we suppose that it is a very smaller time period, but compared to the direct nuclear reaction, this time duration of compound nuclear reaction is quite longer one. And this is obvious because this is not the single step reaction, but this compound nuclear reaction, this is a two-step interaction, right? So in this way, the direct nuclear reaction and compound nuclear reaction can be explained. But the things will be more easier if you do the comparative study of direct nuclear reaction and compound nuclear reaction. This is always very beneficial from the point of view of your exam. So what are the differences between direct nuclear reaction and compound nuclear reaction? Let us see. The direct nuclear reaction requires shorter time duration, whereas compound nuclear reaction CNR, it requires a longer time duration, right? Direct nuclear reaction DNR is a single step reaction. CNR is a two-step reaction, wherein compound nucleus formation is one step and disintegration of that compound nucleus is another step. In DNR, the incident particle interact with only one nucleon. It interacts with only one nucleon of the target nucleus. But in CNR, the incident particle interact with all nucleons of the target nucleus. All nucleons of the target nucleus. Even I should not say it as the almost all. It interact with all the nucleons of the target nucleus, right? In direct nuclear reaction, NDNR, as I have said, the angular distribution of ejected particle, product particle, is strongly forward peak, whereas in case of CNR, the angular distribution of ejected particle is isotropic. That is, the ejected particle could be or could travel in all possible directions, right? In DNR, in DNR, the incoming particle interact only with the nucleon that is present on the surface. That is, any nucleon that is first in the interaction process. So we can say the direct nuclear reaction happen on the surface of target nucleus, right? Whereas the compound nuclear reaction, it happens inside the volume of interacting nucleus, and that's why the incoming nucleon could interact with all the nucleons. Generally, this direct nuclear reaction is a high energy phenomena, and comparatively, the CNR is a low energy phenomena. The examples of direct nuclear reactions are stripping reactions and pickup reaction, wherein there is only one nucleon, either could be absorbed or could be ejected in this stripping and pickup reaction. These are two direct reactions. Whereas in case of nuclear reaction, compound nuclear reaction, you can say radiative. We have already seen the radiative capture reaction is an example of compound nucleus reaction, right? I hope you have enjoyed this session. If you have any query, feel free to ask me anytime, anywhere. Thank you.